Okay, the purpose of this video is to introduce part A of experiment number 1. In this portion, you're going to be introduced into using a function generator, a digital function generator, an oscilloscope, and also a multimeter, voltage multimeter. Just wanted to kind of introduce you a little bit to how to use the function generator. The name kind of gives it away that it generates functional waves, sine wave, triangular waves, square waves, and it also, you can set the frequency and the amplitude as well as what's called a DC offset. Again, AC and DC voltage are related to each other in the sense that DC is a constant voltage, whereas alternating current changes according to a sine function, and that sine function actually is related to the DC voltage in the sense that the DC voltage goes through the 0 point of the sine function. So here is our, see if we can focus in here. This is the digital multimeter. Let me try my best to explain how to use it. First off, here are the different modes that you can look at. You have different functions that you can set by simply pressing on the function mode. You guys are going to be using a sine wave. So you set the light so that you push this button until the light highlights the fact that you're on a sine wave. And you want it to be in continuous bursts or continuous sine wave. So you press continue. Make sure it's on, that this portion of the mode is highlighted. This in itself is actually the frequency set. Right now it's set to 100 hertz. The reason why I know that is that if you look at here, there's hertz and millihertz. This separation here between these two lines represents a decimal place. So right now it's set to 100.0000 hertz. And the way to change that is, if you look here, there's a knob, and above the knob there is a left and right cursor. So as you can tell, as I push the left cursor, I move to the left, and if I adjust the knob, as such, you can see that the voltage changes, or not, I'm sorry, the frequency changes. So since I want it set to 100 hertz, I'll leave it at 100 hertz. Again, that's 200, 300, 400. And again, you can move the cursor to any point. You know, if you want to set it to 100.0001 hertz, I just did. So we're going to leave it at 100 hertz. The other thing that is of interest to you is the amplitude. Here are 4 ranges of amplitude. Here that means that you can set the amplitude to plus or minus 10 volts or a range of 20 volts, plus or minus 2 volts, plus or minus 0.2, or plus or minus, I'm sorry, to a range of 0.02 volts, which is plus or minus 0.01, 0.2, which is plus or minus 0.1, so forth and so on. So you want to set it to the highest range, which is 20 volt range. And then this adjusts your amplitude. Turn all the way to the left for minimum, all the way to the right for maximum. I'm going to leave it on maximum. The other piece of equipment that you're looking at, as you can tell, the function generator outputs a signal and it's split to go to 2 different recording devices. One is a digital multimeter. This digital multimeter allows you to look at voltages, whether it be AC or DC. Right now I've set it to record AC voltage, and you can see that right now it's set to 7.5 volts AC, and as I adjust the voltage, which I'm doing with my right hand right now, you can see the voltage dropping. So right now it records what's called an RMS voltage, which you should have an idea of what that means by looking at your lab handout. You can see right here it says true RMS multimeter. So right now that is the RMS voltage for AC. The other end, we have a oscilloscope. You may have had some introduction to using oscilloscopes in your physics class. This oscilloscope is a little newer, I think, than what you may have used in physics, but even if it's not, I still want to give a little bit of an introduction. It has 4 channels, 1, 2, 3, 4. Right now we're only using 1 channel, which is the output from the digital multimeter, which becomes the input to, I'm sorry, the output from the function generator, which ends up being the input to the oscilloscope. There's a lot of buttons here. I'm only going to introduce you to a few. First off, when you input a signal, in order to be able to set the right time domain, what does that mean? That means right now this x-axis represents time, and the y-axis represents voltage. And as you can tell, this 5 volt right here is telling me that each square is 5 volts. 4 milliseconds, each square horizontally represents 4 milliseconds. I have 100 hertz, which means that for every hundredth of a second, I have a full cycle going through. So if you look at, according to 4 millivolts or 4 milliseconds, you should be able to count that for every 1/100th of a second, you have one cycle going through. If you don't know how to set the oscilloscope, the easy trick is just to push auto set. If I press auto set, what it does is that the oscilloscope allows the time window, the X, and the voltage Y to be set in such a way so that you can see the signal. On top of that, there is a lot that you can do in being able to look at different characteristics of your input wave. And it would take a long time to show you everything, but just as a few things to look at, if you press measure, up comes a menu where all of these buttons represent different selections you can make. Add measurement brings up a bunch of different things that you can look at. Here you can actually use the knobs to select different types of characteristics of the wave that you want to look at. So let's say you want to look at amplitude, right? You turn this knob until you hit amplitude, and then you press here, OK, add measurement. And here you'll have a little dialog box that appears that'll give you the amplitude of any input frequency for channel 1. Keep turning the knob, you can find other things such as RMS. Looking at RMS, so add measurement. Let's say we stop there, right? I press menu off, gets rid of the menus, and the RMS voltage, which is right here, 7.52 volts, and the amplitude stay. So you can tell the RMS voltage, 7.52 volts, matches approximately what the the multimeter has. And there's other things that you can add, and the instructions in your lab handout should ask you for those. Everything else I think you can pretty much figure out on your own. The purpose of this video is not to highlight exactly how to do every aspect of the lab, but to give you an introduction so that you're a little bit more aware of the equipment that you're going to be using once you get here. So this concludes experiment 1, part A.